Hey guys, I'm going to give you some hints for page 202-203. So here we go. I'm not going to worry about 35. I think it's not too bad. 37's not too bad. 39's not too bad. Starting at about 41, people get a little bit confused. So when I see number 41, here's my hint. On the left-hand side, it says cotangent theta plus tangent theta. What's on the other side? Well, the other side says secant theta, cosecant theta. Well, I could turn everything in here into sines and cosines. That would be the way to go, probably. So I would say here, how about we make this guy, whoops, where am I putting a 1 there? Duh. Let's make this guy cosine theta over sine theta plus sine theta over cosine theta. And then get a common denominator. You get a common denominator to this, and it should bring you to where you need to be. I don't want to give you the whole answer, just a hint, but that would be my start for 41, because these guys can be turned into 1 over something, you know, I don't want to tell you the whole thing, but I want to see what you do. Now, number 43, I would say to turn that thing into a double fraction and a double fraction. That would be my first guess. I would look at that and say cosine alpha on this side. Then we have secant alpha plus sine alpha over cosecant alpha equals, and there's stuff over there, but see, when I see this, I'm thinking that this guy right here could be written like this. This guy right here. And then I could cancel out the double fraction. Plus, I could do the same thing here. And then I could multiply top and bottom by something to knock out the double fraction. And then, on the other side of this thing, it says secant squared alpha minus tangent squared alpha. And then, when you start seeing secants and tangents in the same thing, that's when you start thinking, you know what, tangent squared alpha plus 1 equals secant squared alpha. That's when you start looking for that kind of thing. And you do a substitution. That's what I would do for 43, my hint. Now, I'm giving you really huge hints. So if you're just stuck, you might want to, you know, look at the very first part of my help and then try it on your own. And then here we go, 45 cosine 4 theta to the 4th, equals. Now this one, I thought this one was the sneakiest one of all. Well, it's in the top 2. Because on the one side you have difference of squares. That's what you have, okay? And if you factor that thing like difference of squares, you're going to see it. But here's the sneaky part. The sneaky part is right here. I'm going to use a version of this thing. What are they using? Theta. Cosine squared theta plus sine squared theta equals 1. I'm going to use a version of this, but here's where they're sneaky. 2 sine squared theta is the same as sine squared theta plus another sine squared theta. That's what 2 sine squared thetas equal. And then you have this minus 1. This part didn't go away. And it all depends on where you visualize your parentheses, and you should find the result you're looking for. So there's my hint for 45. Now, 47. Let's look at that one. This one is a classic. You're going to see a lot of this in our next lesson. But you know what, guys? This is the hardest thing I have to teach you all year. is how to do identities. That's why I wanted to start it early so that we have time to play. We are going to do some, I'm going to take the heat off a little. Oops, that's a cosecant. Let me undo that. Cosecant x squared. There we go. Next week, we'll do some computational trig. Computational trig is number crunching. It's much more gentle, but this is the heavy-hitting stuff. Now, here's the deal with this. Cotangent x minus cosecant x, quantity squared. We're going to have to square that thing, and if I do that, I will end up with some state, if I did, and there's two different ways to do this one, but if you look at this and you go, you know what, I'm tempted to square this thing. If that's where your brain went first, it's okay. You know what, if you FOIL it, it's not wrong. You can do it this way, but what's going to happen is you're going to end up with some cotangent squared stuff, and you're going to end up with some secant squared stuff. And that's my cot one. Oh, sorry. Sorry. I meant to write cosecant. Whoops. Ooh, here we go. Cosecant squared. See, there's a relationship there that you're probably going to want to use on this side to make it work out. So here's the thing, though. You got to work on both sides on this one. 47's a jerk because you definitely cannot do it easily unless you work on both sides. But here is something, for those of you who have sent me photographs over the email, this is something that you have to embrace. This guy right here, I'm just writing it down separately, away from the rest of the noise. This is hint number 6 from that brown box on page 197. They say if you see something that looks like this, you should try something that looks like this. Now, here's the problem. Some of you are tempted to then cancel the two things you just put in place. I've seen it. You've shown me your work, some of you guys. Don't cancel it. What they want you to do is FOIL everything. So look, if I FOIL the bottom, we'll do the denominator here. If I FOIL the bottom, I get 1 times 1, I get a 1. 1 times negative cosine x, I get negative cosine x. 1 times positive, I get that. And then last but not least, I get negative cosine squared x. That's what I would get if I FOIL the denominator. These would cancel, and then this is what you're looking for. This guy is equal to sine squared. That guy is equal to sine squared. That's why they want us to go for that trick. Now, in the top, if I FOIL it, let's look at the numerator. I gave myself a little room here. If I FOIL the top, I get 1 times 1, and then I get a negative cosine x. I get another negative cosine x, and then I end up with a positive cosine squared x. Now, don't be fooling yourself saying 1 plus cosine squared x is sine squared. It's not. That is a lie. It is a lie. You will not get eagle powers. But what you will get, I'm going to scroll down a little bit. What you will get out of that mess is this. 1 minus 2 cosine x's plus a cosine squared x. Now that's the numerator if I combine all those like terms. What's on the bottom? We just did this. Sine squared x. Here is a trick you're going to want to use a lot. Should it raise its ugly head? There's 1 over sine squared x. Minus 2 cosine x. Now check this trick out. Sine x times 1 over sine x. Look at that. That's slick. That is really sneaky. Plus cosine squared x over sine squared x. Hey, basically I just did this problem for you because you can rewrite this guy. You can rewrite this guy and this guy and this guy. And what were you shooting for? Something over here that you foiled, right? That's what you're looking for. If you foil that thing. So this one is sneaky because once I get it to this section down here at the bottom, this foiled out version, I'm going to call it the foiled result, will match. Okay, let's keep going. Where did I leave off? That was 47. Now, number 49, let's see, here's my hint for number 49. It says cosine theta plus 1 over tangent squared theta. What does it equal? It equals cosine theta over secant theta minus 1. Now, here's the sneaky thing with this. When I see this, I can do the same trick I did in the last one. I can do secant theta plus 1 times the top, secant theta plus 1, top and bottom, right? If I foil the bottom, I should notice something because I know how to tan in 1 sec. I know that. That's my key to the bottom. But in the top, you just have to distribute and be very aware of what you're about to see. This is a right-hand only identity. Now, here's something I noticed people have been posting pictures of their work. Here's something I noticed that is a very, very bad thing. Some people are going, oh, since this is true, I bet you if I did the square root of both sides, then this is true. And this is not true ever. You cannot take the square root of a, I'm going to scroll down, Pythagorean identity. So the cot 1 kisk thing, you can't take the root of both sides. The tan in 1 sec thing, you can't take the square root of both sides. This right here is true. This is never true. Ouch. So watch out. But there's my hint for number 49. All right, here we go. And we're going to number 51. Okay, 51. Check this out. 1 minus sine theta. And then they have plus 1 over 1 plus sine theta equals 2 secant squared theta. All right. Now, one of the hints in the brown box is use the more complicated side, go there first. Now, sometimes you want to start there, but it doesn't mean you have to finish there. But this guy's going to get this trick. This is hint number 6 from the brown box. If you see a 1 minus sine theta, you multiply it by a 1 plus sine theta. You see the other thing, then you do the other thing. But here's the deal. In any identity, it is illegal to treat it like an equation. You do not get to multiply, everything by the same dude. You don't. So let's see what happens here. If I foil this, it's the same as what's going to happen here. I'm going to get the identical answer, which is, this part here is going to be 1 minus sine squared theta. That's what it's going to end up being. You can check it. Well, if it's 1 minus sine squared theta, hey, that's using that Pythagorean identity. This guy's going to be the same dude. But guess what? They are both this. That's what they are. So let's take a look at what's in the top then. 1 plus sine theta. I just got common denominators. Without even trying, it ended up being a common denominator. And kaboom. Huge major hint. You figure it out from there, but that's that. All right. Now, number 53. Here is 53. Let's get working. This guy is a jerk. He's the only, this one, if you do it the right way, it's 2 steps. You do it the wrong way, you could make up 9, 10 steps and still not get there. That's why this one is such a poop. So here we go. And 1 minus tan alpha. Okay. All right, guys. Now, when you post your work to me, if you like take a picture and say, I'm stuck here, can you help me? If enough people get stuck in the same spot, I'm just going to do this again because I'm trying to think of any way I possibly can to help you. But here's the thing with this one. I'm going to just use this. Caught one kisk. I caught a kisk. That is a true statement, super true forever. You cannot take the square root of it, so you cannot just say, oh, I could take the root and put a cosine or a cosecant on the top. No, no, no. Here's the other thing. If I tried to use the same trick that I just used, let's use this trick, right? You're thinking, yeah, that makes a lot of sense. It's a bad trick. Here's how you know. Here's how you know you're going down the wrong path. If I were to FOIL the bottom, if I FOIL the bottom, I will get cotangent squared alpha minus 1. Cotangent squared alpha minus 1 is not what that says. It's really close, but it's not the same thing. So this is called a dead end. When you see that it's something, I can't manipulate this statement. I cannot manipulate this to make it look like the other. You know to give up that strategy. I say this is when you know how to abandon ship. Abandon that. So how do I do it? I'll do one side. You guys can figure out the other side and see what happens. When you notice that it's not going to give you what you need, then, whoop, I'm going to have to, here we go, cosine alpha, sine alpha. This is what you would do. You would take this fraction here, and you would rewrite it and make it a double fraction. Double fractions are not the enemy sometimes, but how would I clean up this double fraction? I could multiply the entire top part by sine alpha, and I could multiply the entire bottom part by sine alpha. And if I did, in the first part, what's going to happen? I'll get the sine alphas to cancel, and I will get this statement. In the bottom part, I'll get the sine alphas to cancel, and I'll get this statement. Now, once you got rid of the double fraction, just take a second. Here's where I'm trying to go with this. If you take that part that I just circled and you write this as a double fraction and bust the fractions, you're going to find a match. See, you guys are practicing this. This is a brand new trick, and it's like a huge puzzle. Every problem is a different puzzle. But the more you play, the better you get at it. I hate to say it, but it's true. You stop making mistakes that you used to make, and you make brand new ones. And then you stop making those mistakes, and then you finally start achieving stuff that you want. So there's 53. Now, 55, might as well give you a hint all the way through. 55 says this: cosine theta over what does it say? Sine theta cotangent theta. And it says it equals 1. I don't know if you guys are looking at it the same way I am. I'm just looking straight here. That this guy right here times cotangent theta is that. And then I just take care of business. That's it. So 55's done. Oh, I wanted to make a point before I move on. Sorry, I got to go back up here. Oops, oops, oops. Okay. Since I already messed with the left side, let me look at the right side. Never do this. Never jump the gun. Remember, this is a binomial. This is a binomial. Do they match exactly? No. So don't be jumping the gun on me. Okay, that was number 53. Revisited. I wanted to do that. Okay, so here we go. I'm going down to 57. And this is our last problem. Number 57. And if you do the first step correctly, this thing is done in one step. So here we go. They want this thing to say this when they're done. That's what they want. Guess which side I'm about to work on? The more complicated looking side. And this is why before we started doing this, I made you guys do problems 13 to 22 all on page 202. That's why I made you do those. Because this guy up here is the difference of squares. And I can factor it. And then I can cancel it with the bottom. But don't jump the gun. Do not pull one of these guys on me. Ouch, ouch, ouch. The top part's a binomial. The bottom part's a binomial. They don't match exactly. Do not do that. Okay, so there's my hints. I'm going to post this for you guys. Actually, they're really severely detailed hints. So you might want to look at one, see what I did for my first move, and then turn off the video and try it yourself and then double check your work against mine. Also, I didn't write out every step formally, and you did not see me draw in any boxes and color them in because that is your job. All right.